Now we will discuss about the metallurgy of copper. Metallurgy of copper. Ore which is used in metallurgy of copper is copper pyrite, and the formula of copper pyrite is CuFeS2. It is a sulfide ore. Now steps involved. Now we will discuss about the steps which is involved in this whole process. First step is crushing and grinding. As we know, firstly we obtain ore from mines by mining, but the particle size of ores after mining is very big. It is present in form of big lumps, just like this. These are the big particles or a big body of ore, and this is form of big lumps of ore. So firstly we need to reduce the size of these particles, so we used crushing, and after crushing of these ore particles, this will be converted into a small size or a reasonable size particles, just like this. So in this process we crushed these ore particles and converted into reasonable size of particles, and these particles are known as crushed ore, and this process is done by crushers. Generally we use gyratory crusher, and we can observe the diagram or a photograph of this crusher. This is a crusher. By this crusher we crush the ore into a reasonable size of particle. Now second step, that is grinding. Here we obtain reasonable size of particles or small size of particles by crushing, and this is known as crushed ore. Now we introduce these crushed ore into stamp mill or ball mill, and by these apparatus we are doing grinding, and after grinding these particles converted into powder form, just like this. So we can say that we further reduce the particle size of ore. This is a powdered ore, or it is also known as grinded ore. So after grinding we obtain a powdered ore. The particle size of ore is very small, and we need to reduce the size of particles, because when the particles converted in a small size, the surface of area of particles will be enriched. So surface area will be enriched, we can say that, then the reaction capacity or reaction tendency will also increase, or speed of reactions will be increased, because reaction is depend on collision and also on a surface area of reactant. Now next step, and we are doing this grinding in stamp mill or in ball mill, and we can observe the photograph of ball mill here. This is a ball mill. In this mill we introduce some balls and ore particles in this cylindrical space, or in inside of this cylindrical space, and we will rotate this cylinder on high RPM, and we observe that the balls will strike or collide with the particles of ore, and the particles of ore become in small size, or become reduces in very small size. So after collision of balls and ore particles will break down and converted into very small size, or we can say that in form of powder. As much as the speed of the apparatus, and as small as the particles will be formed, or the number of balls or the frequency of balls also affect the particle size. So after this ball milling we get the powder ore or a grinded. Now next step second, that is concentration of ore. Concentration of ore, this is also known as enrichment of ore, and this is also known as purification of ore. So now we will discuss about the concentration of ore or enrichment of ore or purification of ore. In this process, we need to remove the particles of gangue or impurities from the pure from the ore particles, and we get pure ore particles. So this process is known as purification of ore because we get pure ore particles. And after removal of gangue particles or impurity particles, we obtain high amount of ore particles, or we can say that ore will be concentrated. So this process is known as concentration of ore. So in this process we use grinded ore which contain the particles of ore. Suppose these are the particles of ore, these pink particles are of ore, and we can represent particles of impurities by white. Suppose these are the particles of impurities which are mixed with ore particles. These are the particles of impurities. So we can say that grinded ore contains impurities along with ore. So now we're doing concentration of ore. Concentration of an ore. And after concentration of ore we get concentrated ore. And concentrated ore contains mainly particles of ore, or we can say that this is pure ore, and these impurities which are present is known as gangue. So in this process we remove gangue from ore particles, and this is done by froth flotation method, because copper pyrites is a sulfide ore. Copper pyrite is the sulfide ore, and we know that for sulfide ore we use froth flotation method. Now we'll discuss about the froth flotation method. Froth flotation method. Now we will discuss about the froth flotation method. Froth flotation method. And this is based on the principle of wetting property of ore and gangue particles. Wetting properties of ore and gangue particles. If there is a difference in wetting property of ore and gangue particles, then we can use froth flotation method. Difference in wetting property means some particles wet from oil very quickly, or some particles wet from water quickly. If particle wet from oil firstly, then they will become lighter, and the particle will become wet with water, then they become heavy and will sink down. So we can say that if there is a difference in wetting property of ore and gangue particles, then we can use froth flotation method. And we know that sulfide ores firstly or quickly wet with oil compared to water. So we can say that if we enter sulfide ores in mixture of oil and water, then sulfide ore become wet with oil, not with water. If sulfide ore contain the impurities which wet with water quickly and ore particles wet with oil quickly, then we can use froth flotation method. So we can say that in sulfide ore particles, pure sulfide ore particles wet with oil quickly, and the impurities will get wet with water firstly or quickly. Wet with water quickly. As we know, copper pyrites is a sulfide ore, so we can use froth flotation method for copper pyrites. In this process we use the following arrangement. In froth flotation method we use this arrangement. In this we use ore, water, pine oil and sodium ethyl xanthate, and also compressed air here. So firstly we introduce water plus pine oil, which is used for making froth. So it is a frothing reagent. Pine oil is a frothing reagent which is used to make froth. Water plus pine oil plus ore particles. Ore particles also contain gangue or impurities, and we need to remove these ore particles from these gangue particles from this ore. And after mixing these particles, we blow compressed air from there. Here we use the mixture of ore, water plus pine oil and gangue particles. And also we add sodium ethyl xanthate. Sodium ethyl xanthate also with this mixture, and this is known as collecting agent. So mixture of water, pine oil, ore, gangue and sodium ethyl xanthate introduced here, and we blow the air from there. And when air blow in this solution, there is a formation of bubbles or lather take place. In this whole process, the particles of ore, suppose we represent the particles by pink color. These are the particles of ore, and the particles of impurities is of white color. Suppose these are the particles of impurities which are mixed with ore particle. When we introduce these impure ore, this is ore plus gangue into pine oil plus water and sodium ethyl xanthate, the ore particles that is represented by pink color, the ore particles will be become wet by oil. This is oil. So we can say that the particles of ore will be covered by oil, and the particles of impurities that we are representing by white color will be wet by water. As we know, the density of water is higher than oil, so water will be sink and oil will be float. So we can say that after some time the particles of impurities will become heavier and come to the bottom. So we can say that gangue will be collected there because it is wetted with water and this will be become heavy. But the oil particles which is but the ore particles which is covered by oil is very lighter, so they will be float here and there. These are the particles of ore covered with oil will be float here and there. They will not sink. And when we introduce air, air produces bubbles. Air produces bubbles, and when bubbles go up, then the sodium ethyl xanthate attract these bubbles from the particles of ore, and these bubbles stick with ore particles, and when these bubbles come on top, they will also attach with ore particles, so ore particle will also collected on surface. So we can say that after some time the ore particles will be collected on the surface, and so ore particles will be collected there. And we can say that here sodium ethyl xanthate is help to attach the bubbles from ore particles and collect ore particles on top, so it is known as collecting agent or collector. And pine oil is used to make froth, so it is known as frothing reagent. So after some time we get ore particles on the top and gangue at the bottom, and we collect the froth in another container, and we add some dilute acid in this container. We add some dilute acid in this container. This will break down the oil particles or other oil particles and ore particles from each other. So they will detach the oil particles and ore particles, and the ore particles will settle down at the bottom and the oil particle will be float on the top. And now we get concentrated or pure ore particle here, and the oil or another impurities will be float over this solution. Now we get concentrated ore particles by this method. Step third, that is roasting. Roasting is heating in presence of air. As we know, this is sulfide ore and we use sulfide roasting for sulfide ores. Because sulfide ore doesn't contain oxygen, so we introduce oxygen by air. So roasting is done in case of copper pyrite, and this is done in reverberating furnace. In roasting we used concentrated ore, and we done roasting here, and after roasting we get roasted ore, and this is done in reverberating furnace. And we can observe the photograph of reverberating furnace here. This is a reverberating. In this furnace we introduce concentrated ore here. This is a concentrated ore, and this is some combustible substance. After combustion it produces heat, and we also introduce air in this furnace and heating this whole ore, and the unwanted impurities or unwanted gases which is formed will be expelled from there. This is a chimney, so gases which will be formed will be expelled from this part, and in this process we get following results. First, sulfide ore converted into oxide ore. We can use following reaction: CuFeS2, that is copper pyrites, plus oxygen which is obtained from air, and now we heat this mixture and we get copper sulfide plus iron sulfide plus SO2 gas. And now we can balance it by writing 2 here and also 2 here. Now we can say that after this we get copper sulfide and iron sulfide, and then copper sulfide or cuprous sulfide react with oxygen further and it get converted into copper oxide plus SO2, and SO2 will be removed, and we can balance it by writing 2 here and 3 here and 2 here. And also ferrous sulfide convert into ferrous oxide, Fes plus O2, and it will be heat and convert into FeO plus, and we can write 2, 3 and 2 here. This process takes place partially, or we can say that after this process some copper sulfide converted into copper oxide and some iron sulfide converted into iron oxide. And second result, removal of moisture. In this process moisture will be removed, and third, some volatile impurities will also removed. Volatile impurities will also removed. Volatile impurities are those substances which has low boiling point, so they will be converted into vapors and will be expelled out from the chimney. So these are the result of roasting. Firstly, sulfide ore converted into oxide ore. Here we get oxides, copper oxide and cuprous oxide and ferrous oxide, and the removal of impurities also takes place and volatile impurities also take place. Now the next step is smelting. This is a reduction process. In this process we get metal from metal oxide or oxide ore. Smelting is done in blast furnace. It is done in blast furnace, and we can observe the diagram of blast furnace. This is a blast furnace. In blast furnace it is a tall cylindrical furnace made of steel, and at the base of the furnace an arrangement for the introduction of hot air, and this is introduced by these turreys. And here two tab present. This is upper tab and this is lower tab. Lower tab is for removal of metal or mat, and upper tab is used for removal of slag. And the temperature decreases from lower to higher height, or we can say that higher temperature is at bottom and lower temperature is at top. and we introduce roasted ore or calcined ore from there. We can use blast furnace for smelting. Now we will discuss about the reaction involved. Reaction involved. As we discussed before, after roasting we get copper sulfide, ferrous sulfide, copper oxide and ferrous oxide. In roasting we obtain mainly sulfides and less amount of oxide because there is partial oxidation take place or partial conversion of sulfide into oxide takes place. Now we are doing smelting here. In smelting, some amount of copper sulfide and ferrous sulfide also converted into oxides, cuprous oxide and ferrous oxide. These oxides is also in form of cuprous oxide and ferrous oxide. So we can say that after smelting mainly we obtain oxides of copper and iron and some amount or trace amount of sulfides, and this is done in blast furnace. And the affinity of iron is towards oxygen is greater than towards the affinity of oxygen towards iron is greater than copper. So we can say that some ferrous sulfide react with cuprous oxide and converted into cuprous sulfide plus ferrous oxide, because the affinity of oxygen is more towards iron than copper. So the oxygen attach with iron in place of copper, or we can say that iron displaces copper because affinity of oxygen is more towards iron than copper. So after this process overall we get cuprous oxide, cuprous sulfide, ferrous oxide and some amount of ferrous sulfide, because ferrous sulfide converted into ferrous oxide, so we get less amount of ferrous sulfide. Overall we get cuprous oxide, ferrous oxide and copper sulfide or cuprous sulfide. So more amount of copper oxide, ferrous oxide and cuprous sulfide and less amount of ferrous sulfide present there, and this is known as copper matte, and this will be obtained in liquid state. And copper matte will be obtained here in a lower part of this. This is a copper matte which contain mainly sulfides of copper and iron and also oxides of copper and iron. But in this process metal is not obtained, so we use another process, that is basemerization. So next step is basemerization. अच्छा ये रबर आ गया क्या? Next process is basemerization. In this process we get metal from metal sulfides. In this process we use copper matte that is obtained from smelting plus silica, that is SiO2 plus air which contain oxygen. And now we done basemerization, and after this, and this is done in Bessemer converter, and after this process we get slag, that is FeSiO3, copper in liquid state plus SO2 that in gases, and due to presence of sulfur dioxide gas with copper there will be some blister form in copper, so this is known as blister copper. When this SO2 trap in liquid copper, when copper become cool and converted into solid, some bubbles like structure or blister like structure will be present in this copper. So this copper is known as blister copper, and it is 98% pure, not 100%, it is a 98%. And along with this blister copper we obtain slag, that is the impurity which is attached with this blister copper. And slag is very lighter than blister copper, so it will float on copper, and we will remove this slag from copper and obtain pure blister copper. And now we will discuss reactions involved. Firstly, ferrous sulfide, that is present in copper matte, react with oxygen and converted into ferric oxide plus SO2. And we can write 2 here, 3 here, and 2 and 2. And now the reaction has been balanced, and this ferric oxide react with silica that we enter in Bessemer converter to remove this ferric oxide, and it will convert into ferrous silicate. This is a ferric oxide is present as a impurity, and this is basic in nature. So we introduce this acidic oxide to remove basic impurity, and this is known as flux, and this is form ferrous sulfate, this is known as ferrous silicate, that is known as slag. So we can say that flux is a substance which attached with impurity and to form slag. Here if impurity is basic, then we use acidic flux. If impurity is acidic, then we use basic flux, and overall they will form slag, and slag will be present in liquid form and they will be float on metal. Then next reaction, copper sulfide react with oxygen and form copper oxide or cuprous oxide plus acid. Now we can balance it by writing 2 here, 3 here, 2 here, and 2 here, and this reaction take place partially, or we can say partially cuprous sulfide convert into cuprous oxide, and some part of cuprous oxide which is formed is react with cuprous sulfide and form copper plus SO2, and we can balance it by writing 2 here and 6 here. And now we can observe that here metal is obtained, that will be in molten form or in liquid form, or we can say molten copper will be obtained from there, and here SO2 gas will be trapped with this molten copper, and this is known as blister copper that we have been discussed before. So we can say that in this reaction self reduction is take place. This is self reduction, no another reducing agent is used in this reaction. There is a self reduction takes place, and we get finally blister copper. Overall ferrous oxide converted into slag, and they will be removed, and blister copper will be obtained in a lower side of the Bessemer converter. But this copper is 98% pure, so we want to obtain 100% pure copper. We use refining process. The next step is refining. Refining is done by electrolytic refining method. In this process we use impure copper that we get after Bessemerization, and use electrolytic refining method, and we get pure copper, and this is done by electrolytic refining. So we will discuss about electrolytic refining. In electrolytic refining we used anode of impure copper and cathode of pure copper. This is the copper which obtained after Bessemerization. This is impure, and we want to remove the impurities from this impure copper, and here we used pure copper as a cathode. There is a thin rod of pure copper and there is a thick rod of impure copper, and here we use the solution of copper sulfate or electrolyte of the metal which we want to purify. And here the copper sulfate solution, copper 2 plus and sulfate 2 minus ions are present. In this method, firstly copper sulfate breaks into copper 2 plus and sulfate 2 minus ion in its aqueous solution. At anode there is oxidation take place. The pure copper atom which are present in this rod loses 2 electron and converted into copper 2 plus ion. It loses 2 electron here and converted into copper 2 plus ion. As we know, ion will not stay on rod, they will come into the solution. So copper atom converted into ion and come into the solution, and the electron which are present here, 2 electron, they will be attracted by positive terminal and enter into the positive terminal. Here 2 electron enter into the positive terminal, simultaneously 2 electron come out from this negative side to maintain the neutrality. Then 2 electrons flow from here and come here, or we can say that enter into the electrode, that is cathode. 2 electron enter into the cathode. Now at cathode, here reduction take place. Here the ions which are present in solution, copper 2 plus ion, gain these 2 electron and converted into copper atom, because plus 2 charge neutralized by minus 2 charge and it become atom. This copper 2 plus ion come on the cathode and converted into copper atom, and this copper atom cannot survive in solution, they will be stick on cathode. So we can say that there some vacancy create and here some copper deposit. So we can say that this process takes place further continuously, and this rod become thinner and this rod become thicker due to deposition of copper, and this rod become thinner due to removal of copper atoms. And after some time we get very thin layer here and we obtain very thick layer here, and this is the deposition of copper atom on this rod, and this is a copper atom which will be deposited on a rod. Or we can say that after some time this rod will be become thicker and this rod become thinner due to removal of copper ions. And in this solution, one ion come into the solution, copper 2 plus, one ion deposit on this rod. So we can say that as much as ion come into the solution, as much as ions will be deposited on the rod. So the neutrality or the concentration of the copper 2 plus ion in the solution become constant. So after some time we observe that all the copper which are present in this impure copper will be collected there, or we can say that we obtain pure copper here, and the impurities which are soluble in the solution will be mixed with this solution, and which are insoluble in the solution will be settled down at the bottom of the anode, and this is the impurities, so it is known as mud. And this is present in lower side of anode, so it is known as anode mud, and it contains the impurities like gold, platinum, silver, etc. So we can say that anode mud is also a very precious mixture, but our task is to remove these impurities from copper, so this is known as impurities. So overall we get copper here, pure copper, and impurities there. So we can say that we have been separated impurities from pure copper, and now we get 100% pure copper by this process of refining.